What's up, guys? Welcome back to another episode of Faisal Al Edaily. Today we're going to be doing a Celestia video, but today it's going to be a little different because in my other videos I have specific places I want to go, but here I'm just gonna do a Celestia exploration. So what this means, I'm just gonna click on random stars and stuff and just see what it's just for fun, you know, just click on random stuff I don't even know about and we'll just see it. So I don't have any specific plan today. We're just gonna, explore like that the title suggests, or like the video name suggests, whatever you want to call it. So first of all, let me turn orbits on. Well, that's very chaotic. That's a very chaotic orbit system. But what are? Oh wait, asteroids are on. Okay, wait. Let me press Control comma or Command comma if you're on Mac. I mean, I'm on Mac actually. But I'm gonna go to orbits, and then I'm gonna do fading orbits. Or no, I do want the fading orbits. I want. Oh wait, asteroid. Wait, asteroids are not on. Wait, then what are these? Are these comets? All of these things are comets. What? Okay, it's kind of crazy. Kind of crazy. Okay, where is? Okay, I think we want all of these. Yeah. Okay. So we're done now. So we were on Earth. So let's zoom out. Let's keep zooming out. So here's the sun. You can see Mercury, Venus, Mars, Ceres, the asteroid belt, Jupiter, Saturn, Uranus, Neptune, and oh wait, you can see Pluto, Charon. Nice. Gong Gong. All of these. I can see Orcus and Vanth. What else? Varuna, nice. Rumina, Chaos, Zewioso. I don't know how to say that. Chimney Gagua. What is that? Oh, Halley's Comet. Halley. No, that's not Halley. It's somewhere around here, but okay. And Sedna. Yeah, this is Sedna. Wait, is it over here? Yeah, it is. It's like close here. I guess if you speed up time like a lot, we're going. Okay, now we're on like 2030. You can kind of see. Whoa, dude, what is going on? Oh, it's an earthquake. Wait, you can see Sedna actually. Whoa, what are all these? These are like comets that are getting ejected out of the solar system. Whoa, what is this? One Oumuamua. What is that? I guess it's another comet that got ejected Oort cloud distances. You can see how slow it is, even though we're going right now we're at 14,000. That's the year. Okay. Whoa, it's lagging so much. There we go. Now it's working. But you can see Sedna's still not even moving that fast. Just crazy to think about, since right now we're at the year 84,000 blah blah blah, 84,620. Okay, let's go back to normal speed. Enough blabbering around. So I guess these are comets that got ejected out of the solar system. Whoa, okay. If you have constellations on, try doing that, because constellations, they're not they're not flat. Some can be way further than others, but they can look flat. But look at this. Look at the constellation, the lines. It looks crazy. Okay, so first of all, we got Rigel Centaurus. This is the nearest star. Let's just take a look. Why not? So here's the closest star. It's actually composed of a trinary system, which means it's 3 stars. So we have Rigel Centaurus, which is just Alpha Centauri, and we have Ptolemy, which is Alpha Centauri B. And there is Alpha Centauri C, or Proxima Centauri C, but it is pretty far. It's really far actually. How far is it? I'm not sure. I guess we can land on it. Wait, let's go here. Let's land, or not land, let's just go to it. And then wait, it's not, oh wait, it is moving, but it's just, we have to go real fast. We just went right through it. Okay, so the distance from Proxima to us is 1.5 million. Okay, so let me track Alpha Centauri now. Its distance, 0.19 light years. So that's what? That's a little less than 2 trillion kilometers. So that's extremely far. I did not know it's actually that far. Okay, so now let's keep moving. Let's keep moving. Oh, you can see Fomalhaut, Sirius A, Alphecca. I'm not sure what that is. Oh, Achernar. What else? Nihal. I'm not sure what Nihal is, but The Nebula, I think I know that one. Rigel, Safe, Bellatrix. Okay, you can kind of still see like all the Orion nebulas or the Orion stars. Yeah, they're pretty close to each other. Whoa, look at the constellations. They look crazy. Oh, there's Elnath, Capella, Aldebaran. Let's see what's. Ooh, Acronaut. Or no, we already did that one. It's like a spheroid, if that makes sense. It's not like completely spherical, I think. So yeah, it is like it's like an egg shaped. It's like egg shaped, yeah. All right, what else can we find? Suhail. What is Suhail? It's like a white star, I think. It's like yellow, white. Whoa, whoa. Wait, it's much further than I thought. Yeah, it's like a white star. Can we like? Okay, wow, that's very blinding. Okay, dang. Radius is a lot bigger than the sun. Well, not a lot bigger, but it's pretty big. Rotation period is actually like Jupiter, kind. That's kind of crazy because usually stars rotate pretty slowly, and it's obviously not like well known. Like it's obviously not like it's just what astronomers think. Okay, what is happening? The constellation lines look insane. Whoa. Okay, there's a lot of ant. Oh, it's Epsilon ant. Okay, let's see this. Oh, whoa, this is a ginormous sun. 65 times the radius. Okay, it's like a yellow giant. Yeah, it's like a yellow giant. Cool. Luminosity 600, and yeah, let's see. Rotation period 53 days. I mean, it's just a theory that it is actually. Okay. Well, I want to call it theory. Okay, let's keep going. We're gonna eventually go past our like galaxy. All right. What if I just click random stars like this one? HIP466097. Okay. We have like a whole codes. Wait, whoa, okay. By the way, HIP are like catalogs. Same with HD and all of those stuff. TYC. So the radius is 10 times the sun. Okay, cool. And it's like a yellow sun. I love how Celestia generates these like artificial sunspots. Sunspots. So you can zoom in on them if you want to. Let's go to like, for example, this one. Has these cool sunspots. And it's literally cool because this part is very like much colder than, it's actually 1500 degrees Celsius colder than the rest of the stars. So it's kind of hard to see, but it's right now the temperature is 4600. This sunspot would technically be like what, 3100 if you subtract the thingies. So you can see the penumbra, which is the further point, like the further part of a sunspot, and then the umbra is the coolest part of the sunspots. Alright, let's keep going. Should we just do like random, should we like type in random numbers of catalogs? I might want to actually. Should we try that? Let me try that actually. So I'm just gonna type in random numbers of catalogs, like known catalogs at least. I guess we'll do HD 1237. Let's do that. HD 1237. And wait, it's like a binary system. Okay, so we have A. So this is A, and it has a planet, or is this just like a small star? It follows around A, so it's AB, if that makes sense. It's like the planet. Oh, it is. Kind of looks like Saturn. It's like a ringless and more spheroid-looking version of Saturn. Actually, I think this is like the exact same model as Saturn. They use the exact same model for this planet. Maybe because like astronomers just guessed that it kind of looked like Saturn. I don't know when they saw this. Okay, where's the other star though? Oh, here it is. So there's 3 celestial bodies in this whole like thing. This is the other star. Ooh, it's like a red dwarf. I feel like red dwarf looks very pretty in Celestia. Also, the sunspots, you can very clearly see them now as they're like umbra and penumbra. Alright, we zoom out once again. Wait, there's this really bright star right here, if you see it. HR8254. Oh yeah, HR is another one of those popular little catalogs, you know? Whoa, what is this? Wait, is it 3 stars? Wait, what is this? Oh, it's a planet. Okay, I thought it's 3 stars orbiting around each other. That would basically solve the 3 object problem, if you know what that is. So when like 3 celestial bodies, or let's say stars, there's no predictable like theory on where they would go. It's a really cool hypothesis, little thingy. So it's V Oct. There's a lot of different names for these stars, which is kind of cool. So this one's like a yellow dwarf. Well, it's not really a dwarf. Wait, is it? No, it's actually huge. It's 5. Okay, so it's like a yellow May sequence star. I don't think it's a giant yet, though. Or it could be a yellow giant. I have no idea, honestly. Wait, is this a white dwarf? Yo, we found a white dwarf. Wait, radius is. Oh wait, no, I thought it was 6 kilometers. I thought it was a pulsar or like some neutron star, but it's actually a white dwarf. Wow, dude, that's really cool though. How do we find a white dwarf? And you can see the rotation period is only 30 minutes. So if I just press L twice, you'll see it. Actually, only once. Yeah, you can literally see it at 10 times speed. You can actually see it moving. Can we see it at real time though? I think we can, but it's like very slight. If that makes sense. Like it's very slow. Very slow. But every 30 minutes it rotates, which is kind of crazy actually. I mean, white dwarfs do like rotate pretty fast, so I don't know. So this is the Vox A, and let me see where's the planet? Here's the planet. Yeah, it's Oct AB. Let me look at this. I'm interested. So it's 3 times the mass of Jupiter, so it's pretty big. And it actually has the same model again. That's kind of funny. Alright, let's see. There you can see there is like a daytime and a nighttime, which is pretty cool actually. Also, the temperature is really hot. You can see 234 degrees Celsius. That's pretty hot actually. How far is it from a star? So let me look at the distance. 1 AU. Okay, now 1 AU is like basically the same as Earth, but this is a star with how many times the luminosity of the sun? Doesn't it show? No, it does show. It's 10 times the luminosity of the sun. So it makes sense that it's hot, even though it's the same distance from the Earth and the sun. It's because the star is 10 times as luminous as the sun. Okay, you know what? Let's do one more star, and then we'll move into. Actually, you know what? Let's just move into our galaxy, or out of our galaxy. Okay, you know what? I don't feel like we have. Actually, if you press brackets, you can see the auto magnitude limit at 45 degrees. We just put this up. we have so many stuff. Whoa, dude, it looks like a. Wait, the names themselves kind of form this like spider web structure, kind of like how the actual galaxies do that. But here, like the actual names do that. That's proof that even simulations can run the whole universe. Oh, you can see all of the all of these globular clusters, and also globular clusters are a type of stellar cluster that are out, not on like the flat disk of the Milky Way. It's like out and like up and down of the Milky Way. Some of them are actually further than the Sagittarius dwarf galaxy. Nice. That was way closer to freaking Milky Way. Whoa. Dude, it's like a cylinder. Cylinder is like the best shape. It is the best shape actually. No full stop. Full stop. No further comments. I think these are the large. Yeah, LMC and SMC. They stand for Large Magellanic Cloud and Small Magellanic Cloud. Let's see them real quick. Wait, are these stars? Have we like discovered actual stars in other galaxies? Wait, let me see. No, all of these are just globular clusters. Okay, I was gonna be like, what? SL. Let's see this random globular cluster. Whoa. Okay, it's very concentrated in the middle, and that makes sense because the globular clusters are supposed to be like that. Dang. Wait, so you can see core radius 0.08, king concentration 0.53. So I think that just means that like the concentration is 0.53. I'm not sure what the unit of measurements is. Like 0.53 what exactly? Whoa, you can see all of the singular stars. It would be so cool if you can actually click on them too. As you can see, some of them are like old red dwarf stars, but lots of them are these like white stars. Wait, what if let me hold A so we can go, like you can see on the bottom left, it says or speed. What if we just go? If we just go, do we? Oh wait, yeah, we can't see. We can't actually see it. Dang, you can see all of the stars. Dang, and also these names aren't from the stars; these are the galaxies. But dude, this looks. They look like worms, kind of, or like nerds. They kind of look like nerds, yeah. So you can see here, it's like very not concentrated, but here, that's where the real fun begins. Wait, am I not clicked on anything right now? I don't think I am. You can see on the top left, there's nothing there, so it means I'm not even clicked on. I'm just selected on Cosmos, something like that. So you can see, dang, that's a very beautiful star cluster. I like that. Whoa. Wait, my game. A gam? It's a gam, dude. Whoa, you can see other star clusters too. There's 2 more that we can see. Dang, I did not think they look really beautiful like that. Nice. Let's see this one. R136. Let's see. Wow, they're also in the HD catalog. So not all HD objects are like that. Nice. Or not all of them are stars, I mean. So you can see this one. This one, the stars in the middle are very concentrated, but they're like pretty old actually. They're like red and old, or orange actually. So they don't just use the same texture for each cluster. They're not like boring like that. So that's really cool. I like that. Okay, I think that's enough for today. I might turn this into like a series. So I might run like part 1 on the title. I'm not sure. Maybe I'll change my mind, but yeah, that's gonna be it for today's video. If you enjoyed it, feel free to hit the like button, subscribe if you haven't already, turn the button gray, follow my space on Core, the name will be in the description. And yeah, peace out and try to explore new worlds and find alien life.